society isn't really prepared to take risks. So there are a lot of regulations, again, for good reasons. On the other hand, if you just look at COVID recently, how fast vaccine development was, also using a completely new technology, I found that really amazing. Yeah? So when there is the need and the pressure, things can definitely move faster. But you also mentioned acceptance by society, and in Europe, you know, when it comes to genetically engineered organisms, the whole society is highly skeptical. Yeah? But it's also, in my view, something that's due to simple lack of knowledge. They have this idea of monsters being created by mad scientists in the lab, but they simply lack basic understanding. And I think that's also a responsibility of all of us, just to make the public in general a little bit more aware. Actually, the European Parliament is also discussing at the moment whether these tiny modifications, mutagenesis genes introduced by CRISPR, that this is exempted, and that resulting organisms are not genetically engineered anymore if you don't leave a trace behind, like a selection marker or something. I mean, I think it's slowly moving, but I think all the challenges that the world's growing population faces, I mean, this cannot be handled without also appropriate and relatively fast, with all the safety measures, developments. When it comes to medicine, of course, it takes, I mean, if you look at drugs, after first discovery have been made, how long it usually takes until it reaches the patients. I mean, it's usually 20 years or so. Yeah. So, and I think, I mean, one should also do a little bit to accelerate that. But on the other hand, I also see there's clear progress made. I mean, just talking about biotechnology and tissue engineering, I mean, there are the first clinical trials ongoing with artificially engineered heart tissue, yeah, for transplantation into and on engineered tissue graft there on diseased hearts. So things are moving forward, and I think we should also be aware that we are in a very privileged situation. I mean, we have now technologies at hand, from imaging to bioinformatics. I mean, we were completely unimaginable a few years ago. I mean, when I started to do molecular biology, I started off by isolating my enzymes because they were commercially not available. Yeah? So isolated reverse transcriptase restriction enzymes, very slow. Now you can buy them off the shelf, and you have techniques, again, imaging, bioinformatics, advanced genetic engineering methods. And I think we are in the unique position to take advantage of these privileges. And I mean, I also mentioned that I think one should also give freedom, particularly also to young researchers, if they come up with crazy ideas. I mean, of course, at a certain time point, it's absolutely necessary also to protect your intellectual property, to think about also commercial exploitation. But the starting point should always be a cool idea. Boldly go where the world has gone before. Just look for things that nobody thought about. And I think this is then essentially creating really innovation, and then brings and moves things forward. And I'm pretty sure that all of you here in the audience, all the young faces, if they commit and are motivated, smart, that they will greatly contribute to such progress. And I think this will accelerate even further in the future.
Thank you. Dr. Sanjay Vihariji.
So, thank you. It's a privilege and honor for me to be here. In medicine, the potential is immense. First of all, let's start with nutrition. So, agriculture and nutrition. So what happens is that if there is a person with a kidney disease, then you have to